In this lecture, we will see a proposed version of the initial code incorporating best practices in object-oriented programming, such as proper use of inheritance, encapsulation, and efficient method overriding. The changes are designed to address the inefficiencies and violations identified, making the code more aligned with OOP principles. In enhancing our class hierarchy to adhere more strictly to object-oriented programming principles, a significant revision was made to the animal base class to ensure that all derived subclasses explicitly implement the makeSound method. This was achieved by leveraging Python's abstract base class module, which provides a robust framework for defining abstract methods in a base class that must be overridden by any subclasses. The animal class was redefined as an abstract class by inheriting from ABC, and the makeSound method was decorated with the abstract method decorator. This transformation enforces a contract within our class hierarchy, mandating that every subclass of animal must provide its own specific implementation of the makeSound method. With this change, it is no longer optional for subclasses to implement the makeSound method. It becomes a requirement. If a subclass does not override the abstract method, attempting to instantiate it will result in a type error, effectively preventing the creation of incomplete instances that do not adhere to the intended design of the class hierarchy. By ensuring that each animal subclass defines how it makes a sound, the model becomes more robust and aligned with real-world expectations. This aligns with the principle of polymorphism, where different classes that inherit from the same base class can exhibit behavior unique to their type. Moreover, this approach clearly communicates the expectations for subclasses, making the codebase easier to understand and maintain, so that other developers working on the project will have a clear directive on the requirements for extending the class hierarchy, leading to a more organized and consistent code structure. By changing the attribute to _isAlive, it was explicitly marked for internal use, protecting it from direct external modifications. The kill method was introduced to offer a controlled way to change an animal's living status, emphasizing encapsulation. Additionally, a property called isAlive was created to safely access the animal's life state, setting a foundation for future logic related to an animal's status. Moving on, in the dog class, the constructor was updated to call the parents class constructor, using super.init. This change ensured that the initialization logic from the animal class, including the isAlive status, was properly reused, reducing code duplication and enhancing consistency across the hierarchy. Then the cat class initially duplicated the parents init method unnecessarily. By employing inheritance directly and removing the redundant constructor, the class was streamlined, adhering to the dry principle that we talked about and simplifying the code. Finally, the bird class was adjusted to include a call to super.init in its constructor, ensuring that instances are uniformly initialized according to the animal class's logic. The addition of a fly method, which checks for the isAlive status before allowing flight, demonstrates practical encapsulation and method overriding. This method not only added a layer of realism to the model, but also highlighted the class's ability to encapsulate complex behaviors. Through this systematic approach, starting with the base animal class and moving through each subclass, key OOP principles such as encapsulation and inheritance were enforced. These enhancements made the code more robust, scalable, and maintainable. You can certainly make your own suggestions to improve the initial code, as there is no one-size-fits-all solution in coding, but generally you should aim at providing a solution and explanation that clearly shows your understanding of the principles that we discussed, since this is what your interviewer really wants to see. Thank you for watching, and I will see you on the next lecture.